welcoming you all for my YouTube channel. In this session, I have taken the topic name called partial differentiation. It is a new topic for you. So, as you know, differentiation already, it is called ordinary differentiation. So, in that ordinary differentiation, you have studied, if you consider a function called y equal to f of x, y equal to f of x, you have find out the derivative of that function as dy by dx, which is nothing but f dash of x, where in that function y was depending on x, x is independent variable, you are differentiating with respect to independent variable, you are getting dy by dx called f dash of x. That is called as ordinary differentiation, where in that function there was only one independent variable. So that's why we have differentiated with respect to that independent variable. We got an derivative. That derivative is called an ordinary derivative. So once you came to know what is ordinary differentiation, now let us see the definition of partial differentiation. Now consider a function called u equal to f of x comma y, where x and y are two independent variables, where u is called dependent variable. Now the variable u is depending on two variables. I want to differentiate always. We are going to differentiate always with respect to independent variables, right? So when you differentiate with respect to x, the another variable should be treated as constant. That is called partial differentiation. So as we have more than one variable here, we are considering one variable and differentiating with respect to that independent variable, means the remaining variable will be treated as constant. Such differentiation is called as partial differentiation. As we are considering only one variable, so it is called as partial differentiation. So now let us see the notation and derivatives of u with respect to x and y. So now differentiate u partially with respect to x. So when we differentiate with respect to x, the remaining variable called, how many variables it may be have? So here only we have two variables, so x and y. So with respect to x we are differentiating. The remaining variable called y treated as, differentiate partially with respect to x and treating y as constant, I am going to get partial derivative. It is denoted by del u by del x or ux. It is also called as de by u by x or del u by del x. This is the notation for partial derivative of any function with respect to independent variables. So del u by del x. Now similarly, let us see if you differentiate u partially with respect to y, what you are going to get. So differentiate u partially with respect to y, the remaining variable called x, treating x as constant, So what we are going to get, del u by del y, or it is also denoted by uy. This is the notation of the partial derivative of u with respect to y, del u by del y, treating x as constant. So now let us go with this is called as first order derivative. Let us go with higher order derivatives. Now if you differentiate further, differentiate ux with respect to x again. That is called higher order derivative. So differentiate ux partially with respect to x itself. We are differentiating ux partially with respect to x itself. It means you are differentiating del u by del x with respect to x. You are differentiating del u by del x with respect to x means it is what the meaning. So, or it can be denoted as del square u by del x square, or which means that u x x, u x x. Similarly, if you differentiate uy partially with respect to y. Again here you should treating x as constant here. Treating x as constant. You are going to get del square u by del y square, or you can also denote that as uyy. Del square u by del y square or uyy. Now we can have a mixed partial derivative called ux can be differentiated partially with respect to x, means that gives a higher order derivative. If you differentiate with respect to, instead of x, if you differentiate with respect to y, that is called as mixed partial derivative. If you differentiate uy with respect to x, you are going to get mixed partial derivative. So now if you differentiate this, differentiating ux partially with respect to y, treating, as I am differentiating with respect to y, the remaining variable is what? X, right? So treating x as constant. So what I am going to get? X as constant. What I am going to get here? It is del square u by. If I go with higher order, you came to know that it is going to get del square u by del y del x. Del square u by del y del x. Similarly, if you differentiate partially, differentiate uy partially with respect to x, treating y as constant, So what we are going to get? So we are going to get del square u by, we are differentiating with respect to x, del x del y. But unfortunately these two values are one and the same. Finally, if you differentiate ux partially with respect to y or differentiate uy partially with respect to x, you are going to get the values like this. But finally the value, whatever the outcome, will be one and the same. So that's why I mentioned these two are equal. This is called a partial differentiation. The method of differentiating u partially with respect to x or y, or you may have more than two variables called three variables. Then you can differentiate u, where if you have x, y, z, you can differentiate u with respect to x, u with respect to y, u with respect to z. While differentiating u with respect to x, the remaining variables are y and z. That two variables will be treated as constant. Similarly, if you differentiate partially with respect to y, the remaining variable x, z are treated as constant. If you differentiate with respect to z, then x, y will be treated as constant. This is for three independent variables. Partial derivatives for three independent variables. Now let us see some examples of partial derivatives of u with respect to x, y, or higher order derivatives are also mixed partial derivatives. Let us see. Now let us see the examples on partial differentiation. So if you consider u equal to f of ax minus by, I am considering a general example here. It means that function f is a function of x comma y. It is a function of x comma y. So here f may be any polynomial function or exponential function or trigonometric function or logarithmic function. It may be any function. So we can differentiate partially with respect to x, y. So now let us see the partial derivative of u with respect to x. So differentiate partially u with respect to x, so treating the remaining variable called y, it is nothing but function of x comma y. So remaining variable called y, treating y as constant. So according to definition, we can denote that as del u by del x or ux. So ux is what? So we are differentiating a function itself, f. The derivative of f is what? F dash of whatever the function you are, ax minus by, into differentiate the inside function, the derivative of ax minus by with respect to x, treating y as constant. So derivative of ax with respect to x is a minus 0. Derivative of x is 1 here, minus derivative of constant is 0. So a into 1 is a minus 0. So therefore the sum of this is a minus 0 is a. So you are left out with ux as what? A into f dash of ax minus by. This is what partial derivative of u with respect to x. Similarly, if you differentiate u partially with respect to y, treating x as constant, what you are going to get? Differentiation of u partially with respect to y is denoted by del u by del y or uy. So which is equal to, so I am differentiating the function itself, therefore it is f dash of ax minus by into derivative of inside function is derivative of constant ax is 0 minus derivative of by, b into derivative of y is 1. So b into 1. So minus b into 1 is minus b. Therefore uy is what? Minus b into f dash of ax minus by. Now let us see the partial derivative of ux with respect to x itself. Differentiate ux partially with respect to x, treating x y as constant, what you are going to get? So that is del square u by del x square, or also denoted by uxx. If you differentiate ux partially with respect to x, it is denoted as del square u by del x square, which is equal to uxx. So when you differentiate this function, it is a product of constant into a function. So therefore constant derivative of f dash is f double dash of ax minus by into derivative of this function is what? Derivative of this function is with respect to x we are doing treating y as constant. So a into 1 as same as earlier, a into 1 minus 0. So you are going to get a minus 0 as a into a is what? Finally uxx is a square into f double dash of ax minus by. Similarly, if you differentiate uy partially with respect to y, treating x as constant. So what you are going to get? It is denoted by, according to definition, del square u by del y square, or also denoted as uyy, which is equal to, so here minus b is constant, minus b into derivative of f dash is f double dash of ax minus by into derivative of ax minus by with respect to y, treating x as constant is what? 0 minus b into 1. So which is nothing but minus b. 0 minus b is what? minus b. Minus b into minus b is what? B square. So therefore uyy is what? B square into f double dash of ax minus by. Ax minus by. Now let us see the mixed partial derivative. If you differentiate ux, differentiate ux partially with respect to y, treating x as constant, so what you are going to get? It is denoted by del square u by del y del x, or which is nothing but u y x is equal to derivative, a is constant here, derivative of f dash is f double dash of ax minus by into derivative of ax minus by with respect to y. I am differentiating with respect to y. So what you are going to get? Into 0 minus b. So 0 minus b is what? Minus b. Minus b into a is nothing but u y x is equal to what? Minus a b into f double dash of ax minus by. Similarly, if you differentiate differentiate uy with respect to x, what you are going to get? So del square u by del x del y, which is equal to nothing but uxy, which is equal to what? Minus b is constant, derivative of f dash is f double dash of ax minus by into derivative of ax minus by with respect to x, treating y as constant. So it is a minus 0. A minus 0 is what? A minus 0 is a into minus b is what? Minus ab. So therefore uxy is equal to minus ab into f double dash of ax minus by. So finally I came to the conclusion that uyx, observe uyx and uxy, the values of uyx and uxy are one and the same. That's why we can say that uxy is always equal to uyx. So when they ask to find derivative of ux with respect to y or whatever the mixed partial derivative, they ask one either of the one, you can differentiate, consider ux and differentiate with respect to y, or else differentiate uy with respect to x. You will get the same answer. So this is the concept of mixed partial derivative. Now consider the example. U equal to x cube plus y cube minus 3xy. Now let us see ux. Ux means what? Differentiate u partially with respect to x, treating y as constant. Since u is what? It is a function of xy. U is a function of xy. I want to find the partial derivative of u with respect to x means. So as you came to know the definition of ux, so what is ux now? Ux is what? Differentiate u partially with respect to x, treating the remaining variable as constant. That remaining variable is y here. So derivative of x cube is what? 3x square. The derivative of x cube is 3x square plus a derivative of any constant value is 0 plus minus 3 and y are constant. The derivative of x is 1. So therefore I will get ux as what? 3x square minus 3y. Similarly, let us see the partial derivative of u with respect to y, treating x as constant. Partial derivative of u with respect to y is what? U with respect to y, treating x as constant. So x cube, the derivative of any constant is 0. Plus derivative of y cube. Derivative of y cube with respect to y is 3y square. Minus 3x is constant. Derivative of y with respect to y is what? 1. Derivative of y with respect to y is 1. So therefore uy is what now? So 0 plus sum of this is nothing but 3y square minus 3x. This is what the partial derivative of u with respect to y. Now let us see the higher order derivative called differentiate ux again with respect to x. Differentiate partially ux with respect to x, treating y as constant. So you are going to get uxx which is nothing but what? The partial derivative of 3x square with respect to x is 3 into derivative of x square is what? 2x. Differentiation of x square is 2x minus, as we are treating y as constant here, so 3y is constant, derivative of constant is what? 0. So therefore 3 2s are 6x, that is what? uxx. Similarly, now if you differentiate uy partially with respect to y, treating x as constant, you are going to get uyy, the higher order derivative uyy. So 3 into a term containing y here, so derivative of y square is 2y minus, there is no term called y, so x is treated as constant, therefore the product 3x is constant, the derivative of constant is 0. So therefore you are left out with uyy as what? 6y. Uyy as 6y, uxx as 6x. Now differentiate ux. Differentiate. Now let us see the mixed partial derivative. Differentiate ux partially with respect to y. As I am differentiating ux with respect to y, treating x as constant. What I am going to get here? That is nothing but uyx, or it is also denoted as del square u by del y del x. Del square u by del y del x. So as I am differentiating ux partially with respect to y, treating x as constant, this product, this term x square and into 3 is treated as constant. Derivative of constant is what? 0. Minus 3 is constant. Derivative of y is what? With respect to y is what? 1. So the value of this is minus 3. So now similarly, if you differentiate uy, differentiate uy partially with respect to x, treating, as I am differentiating partially uy with respect to x, the remaining variable called y should be treated as constant, treating y as constant. So what are you going to get? Del square u by del x del y, or it is also denoted as uxy, which is equal to the derivative of uxy is what? The derivative of uy with respect to x. So 3y square, the product of this term is constant, therefore derivative of constant is 0. Minus 3 into derivative of x with respect to x is 1. Derivative of x with respect to x is 1. So minus 3 into 1 is minus 3. Therefore this value is what? Minus 3. So I came to know that uxx, uxy and uyx are one and the same. Therefore I can say that uyx is equal to uxy. So that is what I have told you in the definition of mixed partial derivative. So if you differentiate ux with respect to y or uy with respect to x is one and the same. Understood?